Okay, now we need to look at each chamber individually. So the first is the right atrium. And remember, you have to have these pressures memorized. So the average or mean of the right atrium is 5 millimeters of mercury. Um, the right atrium pressure is the right ventricle's preload, so that makes sense. And when you look at reasons why a pressure might be higher or lower, you have to look ahead. Okay, the heart is a lot like plumbing, and so when things get obstructed or backed up, or when things get obstructed um, ahead, then things get backed up and causes problems behind, if that makes sense. Um, so for example, when the right atrial pressure is high, so here's the right atrium, so let's say that pressure is high, it could be because of tricuspid stenosis, a narrowing of the tricuspid valve, or pulmonary stenosis, which is narrowing of the pulmonary valve. It could be right ventricle hypertrophy, so again, just enlargement of this right ventricle causing restricted flow, pulmonary hypertension, and tricuspid valve insufficiency. Insufficiency meaning it leaks, it allows black backflow into the right atrium. And so once you think about these things, it makes sense. So I don't think it's necessarily, I don't think you have to necessarily memorize this list of things. You just have to think about it. Um, the right atrium is having problems, so it's going to be on the right side. It's going to be on the pulmonary circulation side, is the cause of these things. Okay, so then same thing with the right ventricle. You just have to kind of look ahead. The cause of um, problems in the right ventricle is going to be on the pulmonary side, pulmonary congestion, pulmonary hypertension, pulmonic valve stenosis, a left to right shunt, meaning blood is moving from the left side of the heart into the right, so increasing the pressure. Because I mean, if blood is moving from left to right, that means more blood is on the right side than should be. A high right ventricle EDP, the end diastolic pressure. Again, pulmonic valve insufficiency, or anything that puts pressure on the heart to cause the pressure to back up. So again, not necessary to memorize this list of things. Just know your anatomy and know that a rise in pressure is going to be because of something that's happening ahead of the game. Okay, so the pulmonary artery, remember your dicrotic notch occurs on the downstroke. Um, Here are some causes of pulmonary artery, it being high. Pulmonary embolus, a mitral valve stenosis. Now that one's kind of a stretch, but I'm going to demonstrate that here in a video here in just a minute. Pulmonary hypertension. Okay, the left atrium. The left atrium, remember, its mean is about 10, so you have to know those values. The waveform looks very similar to the right atrial waveform. The difference is it's going to be a little bit higher. It's on the left side of the heart, so the pressures on the left side of the heart are higher. And I'm going to demonstrate in a video here how this left atrium pressure is measured. It's actually measured via the right side of the heart. What they do is they put a catheter into the pulmonary artery and then they seat it deep into a distal pulmonary artery, inflate a balloon, and then through that they are able to measure the left atrial pressure. The left ventricle pressure, now it is actually measured on the left side of the heart, so it's an arterial stick. They actually put and you've seen this a million times, but they put the catheter in the actual left ventricle to measure the left ventricle pressure. So all of these pressures that we've looked at up here, these have all been on the right side of the heart, so a venous stick was needed to access the right side of the heart. And again, we actually measured the left atrium via the right side of the heart as well. The only one of these that I have listed so far, the left ventricle, now that's done on the left side of the heart, so an arterial stick is needed. And then here, our last one, the aorta, also is an artery, so an arterial stick is needed to measure the aortic pressure. And so again, the aortic pressure wave looks very similar to the pulmonary artery wave. It has a dicrotic notch on the downstroke and is indicative of when the valve closes. Okay, this video is just on YouTube, and I'll upload the link. But here it's showing you the catheter in the right atrium, and so here is the right atrial pressure, double humped and squiggly. Now it's passing into the right ventricle, so now you see a ventricular waveform, tall, and it goes clear to the bottom of the scale. Now this catheter is advancing into the pulmonary artery. Once it crosses the pulmonary valve, you will see that it turns into an arterial waveform. There it did, arterial. Okay, now this catheter is being advanced into a very, very distal pulmonary artery, and the balloon is inflated, so that means it's wedged. So now, and it kind of fades, but now it's wedged, and so it's showing you again a double humped and squiggly line, and that is the left atrium here. Now they have deflated the balloon, so now it's back to an arterial pressure, which is triangular with a dicrotic notch. And here they've inflated the balloon once again, so now it is the left atrial pressure, double humped and squiggly. Now they've deflated it, and so now it is arterial, the pulmonary artery.